Welcoming you all for the new video. This video we are going to discuss about mode frequency analysis of a simply supported beam. Last video we have discussed cantilever beam. In this video we are going to analyze the mode frequency of simply supported beam. Here the length of simply supported beam is 1 meter and cross sections are also as on figure, and Young's smallest value 2 into 10 to the power 9 Newton per mm square, Poisson ratio 0.25, weight density 7.83 into 10 to the power 3 kg per meter cube. Now open ANSI software and go to file and create new, then OK. As usual, go to preference, select the structure and then OK. Preprocessor, element type, add, add and delete, beam to node 188 and then OK, close. Section, beam, common section, select the cross axis of the beam, zero point 0.01, 1 and 0.01. Preview. Okay. Next, go to material property, material model, structural, linear, elastic, isotropic, 2 e power 9 and 0.25 and OK. Density 7830 and then OK. Modeling, create, go to modeling and create key points, inactive CS, enter coordinates, key points, inactive CS, enter key points, key points number 1, 0, 0 and then OK. And key point number 2 and 1, 0 and then OK. Fine. Next one, go to lines, straight line, pick 1 and 2, then OK. Go to missing, go to missing, manual, points. $25. Okay. Okay. The beam is missed. Then go to solution, define load, and apply structure displacement on nodes. Select first key point, select second key point, then OK. Y displacement value will be 0, and then OK. And analysis type, new analysis is model, then OK. Analysis type, so option, and enter the value of your mode to extract in 5 and frequency end frequency 10,000, and then OK. Solve counterless, then OK. Solutions done, and then close. General post processor and read result first set and plot result deformed safe. Choose define deformed safe only, and then OK. And second set read result, go to read result, and next step plot result deformed shape, choose deform and deform shape again, capture the image, and so on. This is the way we have to analyze the problem with ANSYS software. Okay, thank you.